Hi, I'm Elisa.
I'm Ramona. Hi, I'm Anna, and we're introducing our design proposal, FLOPOTO, short for Flower Power Tower. We are first-year Bartlett students studying engineering and architectural design.
Our proposal is designed to be a part of a pavilion carnival parade.
We started this project as part of our course for a design module where we were set the brief moving towers. The aim was to build something at least 5 meters high, which can move or be moved as part of a pavilion carnival parade, and it had to be colourful. We were initially inspired by the Shukov Tower.
We were initially interested in hyperboloids, forms which when decrease in diameter, increase in height, or vice versa. We developed our design by increasing the scale, changing the symmetry and curvature, and finally stacking our various iterations.
Several of our group members experimented with hyperboloid structures, which expand in diameter and flatten, or can contract and grow tall. We explored and determined our concept through fabrics, clothing the structure. Our pavilion was all about the representation of a flower and celebrating the welcome of spring, with light and transparent colours highlighting the phenomenal shapes of the hyperboloid. We also incorporated an asymmetrical form that would appear to be a sunflower tilting and reaching to the sun. The tower grows tall, with positive team energy working hard together. The shapes and forms invitingly mesmerized onlookers. This video shows us growing the tower.
The asymmetrical design tilts the top of a tower towards the sun like a sunflower, and it sways in the wind while the colorful fabric flutters and dances. The fabric enhances the reciprocal nature of the hyperboloid, and the continuous swirling motion it evokes.
For our competition proposal, we are developing our design to create a permanent structure. One of the key successes of our project's aesthetics was the fabrics, and their slightly transparent nature that allowed sunlight to shine through and create beautiful glowing colours and striking shadows. We thought about which surfaces received most light and in the different variations of proportion of the height and width of the structure. We therefore decided to develop a solar panel design idea that could open and close the tower at different times of the day when the sun is in different positions. As the sun rises on the east and sets in the west, the structure is in its tall position, receiving the horizontal light. As the sun moves towards or away from solar noon, the structure will gradually flatten and expose the insides of the shapes, receiving vertical light. Throughout the course of the day, we could control the shape of the hyperboloids as to maximize the efficiency and output of the solar panels in the place of the fabrics. In some non-solar panels, we have started working with Solar Cloth, a company working on the revolution of solar panel technology by research and development in making extremely thin photovoltaic cells and creating flexible and bendable laminate sheets. They have made panels for canvas tents, shelters and sails for boats. However, their panels are still not flexible and stretchable themselves. To work around this, we have designed a new fabric which has the central strip of a laminated solar panel attached to an excess of stretchy fabric which will absorb the tension when moving the structure. We will have 8 of these fabrics, 4 on each side facing the east and west, and some non-solar panel fabric for the beauty of the aesthetic. Our design panels and the movement, we developed our ideas for a moving mechanism. We experimented with pulling ropes simultaneously attached to opposite legs of the structure as the principle of our design. We would attach ropes from a central mechanism to each leg, which could be wound up or released by some bobbin. We would attach a step motor to loosen or pull the structure which would be powered by a battery connected to the solar panels and an Arduino controller to program the movement to follow the patterns of the day. Lilac-y blue that integrates 3D model visuals of the movement. We have progressed the bright pinks and yellow aesthetic to a soft, calm lilac-y blue that integrates the colour of flowers with the sky and complements the solar panels. This one shows the perspective of being inside the FLOPOTO. These are some photos combining the new colour with the structure. The new FLOPOTO will be 3 stacked hyperboloids, the base made with 2.6 metre bamboo poles, the central with 2.2 metre poles, and the top 1.6 metre poles. At night we could have LED lighting outlining the inside of the bamboo poles to create an elegant and harmonic glow from the heart of FLOPOTO. Adapted to fit uniquely and could be adapted to fit uniquely for different space requirements. We envision it as a magnificent kinetic garden feature which provides atmospheric coloured lighting at night or for connecting the power supply of the home. Our future ambition is that, if successful, we could transform the market of solar panels and make aesthetic, beautiful fields of FLOPOTOs in the countryside, efficiently generating energy and gracefully moving throughout the day. The nature of beauty in the hyperboloid forms, combined with the fluttering, sheer fabric and gradual movement, will holistically enchant and inspire people. Thank you for listening.